Let's start. So today's lecture is about routing in our own framework. So we are starting a block of 3 lectures where we will create our own backend framework. We will create a routing system, our own templater. So we will be able to create some HTML code with variables, and we will create a mechanism that will insert certain variables inside this HTML. And also we will work with middleware. Middleware is a mechanism to work with requests, to do some stuff before the request, after the request. So we will talk about this in lecture 5, but we already started creating our own backend framework last week, and you had an assignment where you work with WSGI interface. This is our entry point in our backend framework. So you already created your own web server, but for now, no one can use this server except you. Our main purpose is to create a library that can be used by other users. So we will create not just an application, we will create a tool with which other programmers can create their own applications. So this is a main difference between stuff you did before, for example, in Java course, where you created an application, and now we're creating a framework. We're creating like a structure of code with some architecture that other users can use. So we will create some methods that other programmers will use. So right now we are entering in a realm of unknown. So these 3 lectures will be difficult, but you have an opportunity to become a better engineers, because after these 3 lectures, you will be able to, I don't know, I think you will be able to see through the walls. You will see the metrics, basically, I think. So you can like try your best to do this code by yourself, and good luck. So let's start. So basically, I'm giving you a cheat code. So cheat sheet or шпаргалка. So basically, for the next assignment, you need to create such 2 classes and one like example of using those classes. So basically, I'm showing you the interface of classes that you need to create and a real example of usage of those classes. So basically, your API, this is your server. This is something you already have, and the beauty that you can name it as you want. So in Python, we have few backend frameworks. It's Fast API, Flask, and Django. So you can name your framework as you want. You can name it with your name, for example, Katya API, or whatever you want. And then other programmers will create an instance of Katya API and will use Katya API to create their own websites. So as you can see, we have your API and we have the method call. So this is basically your WSGI interface that you already have, but you can see here we have constructor for some reasons, and we have 3 methods: get, post, and add route. And we will talk about what's the purpose of those methods. Then we have route, here also we have 4 methods, and we have the example of usage. Those get and post methods looks, decorators. I will tell you how to use decorators this time. Yeah, and let's start. So let's start from definition of routing. So what is routing is? So basically routing is a process of association of our path that server receives outside. And you already worked with path. For example, it may be the initial route, or for example, home or info, or something like info let's see, contact page 100 topics, or something like this. It's also a path. So the routing is a process of association, the path with the action that we need to perform when our server receives request with such path. So for example, for this, we want to call a function func1. For this, func2. For this, info func. So we basically want to our server to call some function when it receives a request with some path. Very simple. But what to do with stuff like this? So we can, our roots are not static. It's dynamic structures. So user can use a path with some, for example, variable. So, for example, info contacts page is a static structures, and then we have 100 pages, and user can use any page from this list. So, what to do in this situation? We want our function designed in such a way that so we could use this value as a parameter, and inside this function do some operations with this parameter. For example, to load page 100 from the database. So we need to use this parameter, this value as a parameter inside the function. So routing also, it's about not only association, the route, the path with the function, with some action, but also parsing those parameters and passing them also automatically in our functions. So let's try it practically. So you can see that this is our code from previous lecture, and basically we already have here association of some path and some action, but we did it inside call function. So for example, if as I said previously, we want to create a framework to other developers to use. So other developers can't go inside our code and add some elif for their custom path, for example. They can do this, and even if they could, it would be messy and not very scalable for big applications. Because in big applications, you have sometimes dozens of roots, so you can't create them in one place. So let's modify our code to create association of root and some action, and we will try to implement a mechanism to assign new passes with new functions. So let's create a new file, my server, I call my server Octo API. So let's add this function here, and let's remove this part for now. Yes. So let's create a constructor in which we will create a list of routes. So we can create a list of routes, and we can write some routes right now. So let's create not a list but dictionary. So we can add dictionary, and we can show Python that we want routes be dictionary with key as a string and value as a callable. And then we can create our empty list. And for example, we want to create a route for create our initial route. We are showing that this route. So today we have not very pleasant setup, I think, but we have interactive whiteboard, so we can like choose something here. I like it. Yeah, so let's continue. Guys online, can you tell me, is everything okay for you? Can you see the code and can you see the whiteboard? For example, what I wrote it on the whiteboard. Interesting. I can hear you because no, you're just silent. Online guys, are you here?
Yes, here.
So what I just wrote it here. What is this? Can you see? Yeah, thank you. So let's continue. We can create a dictionary of our roots. So basically, we can create such root. We can create a function. We can define a function, for example, initial route action, for example. Okay. Initial route action. And we can do the same logic that we done here. For example, we can just return for example this HTML, and then we have association, we have dictionary with key string and value callable. So we can write something like this. And then, for example, we can check if our path in roads, we can say that our body equals self roads. We can say that our body is a self roads path, because our path is like a key in this dictionary, and our value is a function that we can call, and this is why it's called callable. So we can use this body, but if we write it like this, it means that the body also callable. And callable, the main thing about callable, we can call it. And to call callable, we need to write those columns. And then we will run this function, and we will have this HTML as a return value. And also we can write our status, okay, but also we can do it like this. We can also do something like this and have from our action not only body but also status. So what is callable? It's very important concept because in Python everything is an object and also the functions. So this is our definition of function. You can remember from Java our metaphors about classes and objects. So class is just a blueprint. For example, class car is a blueprint of some car. And when we're creating an object of this car, we're creating an actual car. The same thing is here. When we defining our function, we're creating a blueprint, like a set of actions that will be performed when we will call this function. But we can write something like this. And then our func will be callable. So callable is an object that we can call. This is like a button that we can press. So nothing happens until we press in this button. And like this function will not be executed until we will press on this function. And in terms of code, pressing on this button means we adding our columns. Am I saying it right? Is this columns, right? Columns, right? Yeah, so in this case, we will run our function. But in this case, we're just saying this is an object. So, for example, let's run this code. Let's create a new file. Main. We have main2, because we are very experienced programmers. So what I want to do is to import our Octo API, and I want to create a callable of functions that we defined here, initial road action. We can implicitly or explicitly show that we want this function from Octo API. We want to import this function. So what will happen when we will run this code? What do you think? What will happen when we will run this code? No, nothing will happen. Because, okay, let's add some action. Let's add print hello. And let's remove this return value. So we have print here. What will happen when I will run this file? What I will see in the console? Right, nothing. Because we can run it, nothing. Call.
Solid state is variable.
Yeah, we never called anything. We have a callable, we assigned to a variable object with a type callable, but we never called it. So we can call it. And now here we can see that we have our print value. And beauty of this, that we can pass functions as the parameters in other functions. So for example, we can create also in Octo API some function. We can say choice. And we can take, for example, some flag, boolean. We can take first func callable and second func also callable. And inside this function, we can check, for example, if flag, then we can call our first function that we will get from the parameters. So what I need to write here to call this function? Yes, because if I will write it like this, it's not an action. It's just an object. It's the same I can write like flag. And this is the same. I just wrote it an object, some object. But if I want to call it, I need to add this. And for example, else, I want to call the second function. And then, for example, we can also import our choicer, and we can define here some functions. For example, barking func, and we will print bark. And also we can define what function.
So if let's move our
What? Let's move our class function. Yeah. Moving class func. And this saying
without
yeah. So then we can call our choicer. Our choicer, I need to always feel where your screen here is like ending. So we can call choicer and we can pass some parameters. We can pass them as positional parameters, just like true, barking func, and moving class func. But also we can do this as a named parameters. For example, our flag equals true, and you can see that we need to continue with the named parameters. First func, it's barking func, and second func is moving class func. So we passed those callable, those objects that we can call inside other functions that defined in another module. And then in this another module, we are calling those, we can say callbacks, those callable objects. And here in this function, we even don't know what is this, what will happen. We just created this function to like other module to use this function to pass those callbacks. And we can do here whatever we want. We can change, for example, those functions. And then when we'll run it, you can see we're saying hello because we have hello here in initial route, and we barked because our flag is true. We can say false, and we're moving in another classroom. So this is about callable. And one more thing. What if we want create a function and we want to pass some arguments inside this function? For example, we have some math calculations. For example, some very important math calculations here. And for example, we have here some list of items, for example, and this is very important items that we are creating inside this function. And we want to pass math calculation and a list of items inside our callback. How can we show that we can do this? So here in barking func, we can create two parameters with asterisks and two asterisks. So we can do stuff like this. We can create args and quarks. And what does it mean? Let's print those parameters. So args is all the positional arguments that we are passing to this function. It will automatically check all the positional arguments that we are passing and create a tuple out of them, and pass and inside this args we will have, I will show you. For example, we can have an access to every positional argument with the index. And quarks, it's a keyword arguments. It's when we passing in this function named parameters. And we can have an access to them with a keyword. So let's use and let's create some also named parameters. Let's show our flag. So our flag equals flag, and for example, my name is Vlad. Let's do this true, and let's run it. So so as you can see here, we printed our args, and our args here is 9 and the list of important items. And as you can see here, we passed here, bless you, positional arguments. It's our important calculation, it's 9, and important items, it's a list of items. And we have an access to the first element in list of args with index, and we have our 9. And then we have quarks. It's a dictionary of named parameters that we passed inside this function. So you will use those concepts when you will create your own routing system. So next, let's move on pretty quickly to the concept of decorators. So we can create some function. For example, let's remove all of that. Go ahead. And let's create some functions that, I don't know, simple func. And this function will say just so then, for example, we want to calculate the time this function is executed. We can add module time to do this. And we can create a function check the speed. And for example, we want to check the speed of some function. So we can have this function as a parameter inside this function check the speed. And it will be callable. So we can create a function inside this function and return this decorator. And I will tell you what does it mean, but the thing about check the speed, that we want to have a function as a parameter, and we want to return also a callable, also a function. There. So we are defining function inside this function, and we can do some manipulations. For example, we can have our time start time. We can call our function, because you remember this is a callable, and if we want to execute it, we need to add counts. We can have our end time, and then we can print for example, end time minus start time. So basically, if we want to check the speed of simple func, what we need to do? First of all, we need to import check the speed, this function. Then we need to check the speed and pass to this function to check the speed of simple func. In check the speed, we have only one argument. So what we
need to pass the function.
Yeah.
Well,
we need to not even the function. We need to pass the callable. So we need to pass our simple func, this one, as a parameter to this function. So what will happen when I will run this program?
It's all printed out.
So, okay, it will print I am simple func, and then it will print time of execution, right? No, it will print nothing, cause what?
No, sure.
Because check the speed are not executing this code. You can see we are not executing the code. We are defining the function that executing this code and returning this callable. So in this function, we just defined a new function and return it as a callable. So in this example, what we have here is just a callable. So we can write something like this, and speed func will have inside it a reference to the callable object. And if we want to call it, we need to add columns, because this looks like function, but it returns another callable, another function. So when we run it, we can see that, God bless, we can see, can we see? We can see I am simple func and time of execution, because we called it. So basically, we can do something like this. Insanity. Oh, Maxim, it's not insanity yet. We can do something like this. Yeah, because this part is a function, because this function returns as a function, modified function. And then we call it. But in Python, we can simplify our lives. We can add a decorator. Check the speed. And then we can just call our simple func. And you know what will happen? The same.
Yeah, we say it. Yeah.
Yeah, so the same thing. Because this is a syntax sugar, basically.
Or
1 second more for our time.
something like that, right?
No,
It's just
I think maybe
it just hard.
some hardware issue, yeah. So basically, when we writing this symbol means that this function will take as an argument the definition, the function that we defined under it. And this function, when we will call it, will our interpreter will run not this function, but this function with this function as a parameter and call it. Yeah, so this is decorators. So now let's move on to the practical part. Let's move on to the our so let's talk about so we had here this example, but we need to register those roots out of our class, because we can't say, oh, user, please go inside my Octo API that you can change and change this line of code and add your path here. No, we can't do this. So we can create a decorator to do this for us. So, for example, we'll create a get function that will take as a parameter path, and it will return what? What do you think? What it will return? It will return callable, because it's a decorator. And then we can define our decorator, our function that we call decorator, that we take the callable that we want to assign, action callable. And then we want to add we want to add to our roots value that will have a keyword path and a value of our action. But okay, I forgot self, because we're working inside the class, and we want to return do we want to return something? We want to return action, and we want to return decorator. So let's check what will happen when we, first of all, let's import our Octo API. Let's create an instance of Octo API. So this is our server. Next, we will create this decorator, and we will pass into it our root, for example. Then we want to define a function that we want initial root action. We want to define the function that will be executed, that will be connected to this root inside our Octo API. So, for example, we can use this function. So, and we can print our roots just for test reasons here, and here. So let's run this code. And as you can see, we have created our OctoAPI object. We printed our roots. It's empty because in our constructor, we have an empty dictionary. Then we did this thing. We printed it, and we can see that we have one root inside our roots. So key is our path that we can see here, and function is a function initial root action. So what happened before? When we created a decorator, nothing happened. But now we just define this decorator and already have some action happened inside Octo API. It's because we run our get function first of all. So what's happening? We are running our get function. We are running it. So what is happening? We going here, we creating our decorator, and we creating a logic for our decorator. And as a result, we have a callable. So we can change this part to the callable that we took that as a return value of get. And then we have this decoration syntax where basically inside this callable that we have from the get, we are passing this. So we have as a return value callable that have as a parameter some function, some other callable, and doing this stuff. So basically, because of that, we called our get function, we already did this action of adding roots. You will find more like described theoretical materials in the module, but basically this is how we can register our roots from outside. So basically right now our user of our framework don't need to go inside code of our Octo API. We created a decorator for this user to add any roots that it wants and use those roots here. So now I am, as a user of this framework, can create an object of this framework and then add those roots like associations of path and action outside of this class. And inside of this class, I can create such logic where any path that registered in the roots will, thank you, Maxim. So if you will have questions, you can ask Maxim during this lecture, this week. Yeah, so basically, we automated this process. We as a user of framework, we are initializing our server, then our server initialized, it's working, then first thing that we're doing, we are adding roots, we are adding associations. We are saying, server, please, for this path, do this, for this path, do this, for this path, do this. And then we have very abstract logic. So when server will have requests with some path, it will do what we have set him to do using this decorator. Because we have this table of association of paths and real action that we can do. So this is first part, and we already don't have time. but I also need to explain you what you need to do. So root is not just a association of pass and callable. So you will have inside your init method in your API, not a dictionary. You will have a list. So let's please don't call it your APIs. So inside init, you will have, this is not a Python syntax. I'm just creating a pseudocode for you. A list of roads. So what is road? You can see on the screen, you can see here, road is a class that handles road logic. So inside road, we have init. You can see that init have method, pass, and handler. So what is method? It's a get or post. So basically, with the decorator, we can say that we, for example, if our user of our framework using get decorator, it means he registering a get method. So you can see at add road, this is basically a function that will add a road to our list of roads that we are using inside our backend server. So as you can see, there are three parameters: method, pass, and handler. And basically, we're creating an object of road because we can see that here also method, pass, and handler. So method, we have from the type of decorator, and this is not automated. This is basically inside get decorator, you will print the string get. Inside post decorator, you will print string post. Then pass, you will have as a parameter, and handler, it's an action that you are using inside the decorator. So you inside add road, you creating an object of road. When you're creating an object, you using this function init, inside which, so inside init, you need to create a list of parts of your pass. Because, for example, if you have pass info content 5, you need to split it in a list of components. So you can use a method split. You can use as a split symbol this, what is this? Slash. And then you need to have a list of info, content, and 5. Okay? So this is first action that you need to do inside the road. So inside road, you will have your method pass, you will have your splitted pass for the actions that we talk a little bit later, and you will have a handler, a callable that will be run when it's needed. So how to work with the road? The main thing, when inside your API, you have your call magic method. So when you will have some request with the pass going into your server outside, you will have your pass. And you need to check, you have a roads list, right? You need to check if you have similar paths in your roads. So for this, you doing something like for route in self roads, and you traversing all your roads, and you check if road matches guys offline. You can see this. I have it. I don't have it. Here, matches. We check if this road matches path that we have outside of server. And if our road matches this path, we can call our handler and pass here parameters that we can have from the matches part. So our handler will look like this. So we will have parameters that we have from the path. We will pass it. We will have them from this method, and we will pass them to the handler. So let me tell you about the algorithm of matches. So matches have a method and a path as the parameters. Method and the path. First of all, inside root, we have already our method that we registered. So first action, we check if method that we have outside of this function is the same as that we registered in our route. If yes, we moving on. If not, we returning null, because you can see that matches have an optional type. So optional dictionary string and then the any. So optional means that we can return null. And if our root inside which we created this method, called this method, is not similar of path that we have outside, we return null. And inside call method of our server, when we receive a null, it means we can move on and check other route. So first action, we have our method. If method get, we are moving to path. You know that we already have a method split path. We have saved a splitted path as a list of parts of this path inside our root. So we doing the same thing with the path. We splitting our path. So we will have some list of parts of this path that we want to check. And then, for example, this path we'll call split incoming pass, and we already have splitted just pass. So then we check the length of splitted pass and splitted incoming pass. And if those lengths different, it means already this pass don't match our registered pass. Because, for example, we registered some info contacts and we checking info contacts page 5. In first pass, we have length of 2 of this list of splitted components. And second one have length 4. So this is second check. If the length of splitted incoming pass equal to splitted to length of splitted pass, we moving on. If not, we return null. Next, the most interesting thing. We checking line by line, like the element by element of our pass that we registered and pass that incoming from the outside. So you can see this like something like this. For example, we registered a pass, for example, info page 5. Oh no, we registered info page because if we want to have a variable inside our pass, when we are registering it, for example, in our main method, we assuming that here, for example, info page. If we say that this page is a variable, we are using those brackets. So, for example, we registered this pass, and we have incoming pass that info page 5. What we want to do? We're creating a simple loop where we traversing element by element of those two lists. So first of all, we have index 0. We have element 0 here, element 0 here. We check, first of all, if they start from, if inside our registered root, we are starting from this symbol and ending with this symbol. If yes, we're doing other logic. I will tell you about this logic later. But if we don't have the symbols, we just check if this line of this string is equal of this string. If not, return null. If yes, we are moving to the next index 1. The same for these parts. We check. They are similar. Okay. Then index 2. We are here. And here we can see that our first symbol and last symbol, those. So we say, okay, we will remove those symbols from this line, and we will work with this and with this. So inside matches, we want to return a dictionary of our value that we have from the path, like the name of this variable and the value. So inside matches, like at the start, we're creating the dictionary already. Dictionary with a string key and any value. So when we have such structure, we're saying, okay, we want to add two params, something with a key of page that we registered in our root, and value of incoming path, splitted path value. So basically, incoming splitted path with the index I, for example, or like in this situation, index 2, right? And we will have our dictionary where we have a like value where key is a literal string that we registered and value that we have actually in our path. And if all of those checks passes, at the end of our matches method, we're returning the params. And our call method sees that if matches didn't return null, it means that it matches. And if our params have some information inside it, it means we need to pass these params to the handler that we have inside our root with those asterisks. And this is it. So what we want to do. One more time. We have our, for example, Octo API. We have a list of roads. We have some decorators to append some roads, for example. Then we have our call. When call triggers, we traversing our roads and trying to find some road that matches path that incoming from the request. So we calling we creating a variable param. So we saying, okay, we want our road match path. If params null, we are not doing anything. We are moving to the next road in our list of roads. If params not null, we want to call our road handler and pass our params inside it. This is it. When we are creating roads, we're creating a splitted list of parts of paths that we want to register. Yeah.
From
I believe in you guys, because look, yeah.
What is why do we this specifically direction function? What purpose does it serve around our chapter?
It literally matches the path that we registered. So we say